Okay, so I'm going to screencast numbers 7, 8, and 9, and that's what you'd be ultimately responsible for tomorrow. You notice these are all overlapping triangles, and they all have something to do with CPCTC, because none of them are asking you to prove triangles, they're asking you to prove a part, like FM is congruent to AQ. So let's look at the first one here, number 7. I wrote the givens down, what you gave me there, and I highlighted one of the triangles in pink, HAQ, and what I'm going to do is take that and redraw it off to the side. Okay? And now I've also highlighted the other triangle, which is HMF, and I'm going to take that and drag it off to the side. So what I did there was just separate my two triangles. And now I can go marking what the givens have. HA is congruent to HF. HA is congruent to HF. Okay, so that's going to give me a side because there's one of my congruent symbols. The second part says HM is congruent to HQ. So I can now say HM and HQ are congruent. That gives me another one. Now the third piece of information is actually angle H at the top. If I put these back together and you look at angle H at the top is the exact same angle. We haven't had this a lot. It usually happens with sides, but angle H at the top is congruent to itself. This is not vertical. This is the exact same angle. So we say reflexive property. And that is our third congruence right in a row. And that's an angle. So we have 3 congruences there. Now, I'm going to separate these again. Or maybe just remember how they looked before. Like this. And I marked this side, this angle, and this side. So it's going to be a side angle side situation. And you just have to keep the triangles named correctly. So this one here, I'm going to call it HMF. Triangle HMF is congruent to triangle HQA. And we decided that that was going to be side angle side. You see over here, I reminded myself I have to prove the triangle's congruent first. Even though it doesn't ask me for that, you still have to do that first. And then my last line is always what it asks me to prove. So in this case, it's the part FM is congruent to the part AQ, and that is because corresponding parts of congruent triangles are congruent. Number 7, done. Okay, on number 8, you see I highlighted both overlapping triangles again. Very similar to the picture we had above, not a whole lot different than that one. I am going to pull this one apart and take this one apart. And then maybe we should rename them, right? D is up here, C is down here, G is right there. And on this one, again, it's D at the top, T halfway down, and C in this corner. Or I'm sorry, S in that corner. Okay. So do we know anything from the givens? We have 2 congruences right there in the givens. So DTC was really this entire left side because it was really DTC, but that's over here now. And that's congruent to DGS, which is over here. So all of a sudden we have a side, and then it says angle C is congruent to angle S. So that's right there and right there. That's going to give me an angle congruence. And then because I don't want you to fast forward to where I finish the proof and just hit pause and copy it down, I'm going to talk my way through this instead. The third part is that reflexive angle at the top. It's this angle D, which is really reflexive. If you put it back on top of itself, like it was before, if I take this, you'll notice that angle D is in fact the exact same angle as angle D, right up here at the top. So you would write angle D is congruent to angle D. The reason is the reflexive property, and that would give you an angle. Now if you were to pull those apart again, it would look like this. I just pulled them apart again, and that's one triangle and that's the other. And you'll notice that right here we have angle, side, angle, right in a row. So to prove the triangle's congruent now, you would say triangle, I'm going to say DCG, is congruent to triangle DST, and the reason would be angle, side, angle postulate, or angle, side, angle is congruent to angle, side, angle. Then you would take the prove line. It wants you to prove these congruent parts. ST is congruent to segment CG, and of course the reason for that is CPCTC. There, you learned and you didn't copy. Okay, welcome to number 9. This is another overlapping one, but a little bit different, and I already have the two highlighted, the pink and the blue there. And I am going to take this one over here and take this one over here. It would really be like that, but I don't have room, so I'll do it over here. This would be A, B, C, and this one would be D. Sorry about that. This one would be D, C, B. Now, if you were to put these back together, you'll notice, what do they share? They share side BC. So BC is the reflexive side. Again, if you put those together, B and C line right up. So BC is the reflexive. So we'll get to that. But first of all, the two givens say perpendicular. Now, we talked about in class, perpendicular means 90 degrees, right? So I'm going to go up and mark that AB is perpendicular to BC, and DC is perpendicular to BC, just like the givens told me. Now I'm going to go ahead and name this, say, angle 1, and I'll just call this one angle 2. And I'm going to go ahead and say that angle 1 is congruent to angle 2 because perpendicular lines form congruent right angles, or something very similar to that. You can say that all perpendicular angles are 90 degrees, and obviously, like I talked about in class today, all 90-degree angles are equal. So that's what you write right here as your reason. So that gives us a set of angles here. The one that it gave us right above there, ACB and DBC, that's telling you that this angle and this angle are congruent right here and right here. That was given. So that's another angle. So we have two congruences right there. A minute ago we talked about the reflexive property, and that BC was congruent to itself, BC, and that is the reflexive property. And then we now have enough. We're going to prove the triangle's congruent right here. So I have an angle and a side. Let's see what order that's going to be in. Angle, side, angle. So you can prove the triangle's congruent. You can call them triangle ABC and triangle DCB are congruent because angle, side, angle, angle, side, angle. And then we take the prove line. It wants us to prove parts. So line 7 would be that AC is congruent to DB because of CPCTC. I know that looks like my handwriting because I'm almost that messy, but now you can't fast forward and just copy it like an answer key. You actually had to listen to me. If it was confusing, go back and listen. I do say exactly what to write everywhere, so hopefully you have all this done for tomorrow. See you then.